that business getting into the construction industry when they started making the ceramics that were used for insulators. And some of those old ceramic-based switches, electrical outlets, that continued to grow over time. Technology changed and evolved. Now we're involved in the smart connectivity on that. So you could say we're probably in the green energy business. Primarily, we are dealing with the distribution and management of electrical energy within the commercial and residential buildings. So the part of the smart office building that you're talking about, largely talking about lighting energy management. We're not getting into HVAC that I know of. We do deal with power conditioning and UPS. Think museums, think commercial office buildings, think airports, think NSA headquarters. No. But with wireless and wired technologies, with connected systems, remote service management, security is very much of a forefront concern especially since California and Oregon enacted their IoT security bills. Why are we interested in Zephyr? Because it is a very viable approach to delivering the breadth of products that we have to have for instrumenting buildings. Okay? Now, what I'm going to share is not what we've done inside of Legrand. My particular individual role inside of Legrand, I am part of the systems engineering team, largely working as the firmware architect for secure firmware products, IoT connected products. But a lot of my role at this point is systems engineering. And that takes on a new scope and a new set of responsibilities when you start getting into products that cover security. I don't need this. What I'm going to be sharing is actually due to experience I had prior to Legrand that is related to product line. That's when I worked for another company that you actually may have heard of called Hewlett-Packard on products you may have used, inkjet printers, dealing with a complicated technology you may have forgotten about called fax machines. And it really was a huge learning curve there. A lot of what we did in the early 2000s was we figured out, we were driven the initiative to focus on reuse in our solutions, reuse of print cartridges, of mechanics, all the way along. And that push on reuse drove us to create a product line, which was actually relatively novel at the time. This is not reuse of libraries. I should say it's not just reuse of libraries. It is not just a implementation strategy. It is a whole business strategy, it is a whole governance strategy, all sorts of stuff. Turns out that we were one of the earlier innovators in this. We weren't the earliest. We were one of the earlier ones. And we are actually referenced in some training material created by the Software Engineering Institute at Carnegie Mellon University. Training material they created on best practices in doing software product line. They mentioned other companies like Cummins with some of their motor controllers. I forget some of the others that are in there. I've got links, you can go find it. But software product lines are much bigger than just the IoT space or the device space. There's branches of the military that have used this strategy for some of their ships and instrumenting some of their ships. There's banking, finance kinds of businesses that have used this strategy for how do they manage their pieces of software. So what I'm going to be sharing is how do we take that best practice in software engineering and apply it in an environment with Zephyr? Why? Because those of us that are making devices have to be able to be cost effective. We have to be able to reuse stuff as best as we can, and our devices are different from each other in functionality. It's what we face. Let's go on down through that bullet. Couple other things I need to take care of. For those watching the recording, this session is during the final afternoon of the conference. So I'm actually going to be referencing content from the earlier sessions. I hope you find the teasers interesting. Another thing is, my apologies for all of you. I will probably be yawning. Not only is this session right after lunch, but in my hotel room, the unbranded light switch was triggered by motion sensors. It turned on 4 times during the night. Whoever designed it may have designed it right, they may have done it right, but it didn't do the right thing. In software engineering terminology, they verified it. It passed verification. According to this user's needs, it didn't pass validation. So please forgive me if I yawn. We're going to come back and reference that a few more times inside of here. Okay, so the agenda. We have about 20, 25 minutes left. Like I said, I'm coming from a systems engineering background. Terminology is going to probably be a little bit different than you guys are talking about. We're going to go through defined terminology. We're going to define the general product line engineering process. And then we're going to see how Zephyr fits into that process. Then we'll take some questions at the end. Product line terminology. Here we have a lot of text. I don't care that you read all the text. The important part is these are links to content that I referenced. I am not making this stuff up. The next important piece is whatever's in bold, right? One of the links is for vocabulary. One of the links is for a reference model. One of the links comes to a document that's tools and methodologies. One of the links deals with a feature-based approach to doing this. Some of the other content I don't have direct references or quotes from, but those bottom 2 links are for material that's been really useful for me on training, giving background on what is software product line stuff from the Software Engineering Institute and the, software engineering body of knowledge. Freely available on those things, at least part of the CMU training material. So, terminology. These are terms I'm going to be using. I just need you guys to know what I mean. First, product line actually has a very technical definition. In the ISO and IEEE standards, there's actually a couple slightly different definitions on there. I tried to grab one that would make the most sense on here. Important parts. A set of products or services that share explicitly defined and managed. It's a really key point, and that's one we're going to come back to. Common and variable features. That's a really key thing. Relying on the same domain architecture. You're doing multiple products. They are different from each other, coming out of the same commit. Okay? That's what we're talking about. That's what this standard is talking about for product line. So, an interesting question out of this. Earlier sessions we talked about Google presented their Chromebook embedded controller implementation. Question to consider, is that a product line? I heard they may have been producing 200 firmware images out of that. Is it just different versions of one product? Or is it a line of products that they're doing? I don't know the answer because I don't know how the features vary between them. It is clearly, there's good reasons for either answer. It is not something we're going to get hung up on, but it's something I want you to think about. My experience with this was actually coming from a product line where the scope wasn't a embedded controller for a laptop, but the scope was a code base that could do an answering machine and a wireless camera dock. Oh yeah, and it could do fax. That's a pretty clear breadth of functionality. We can see things plugged together. Okay, so in the previous slide, we referenced domain architecture. This is what they are using for the term domain. The common architecture for a product line that can embrace variability of member products. Note that the architecture contains designs that are intended to satisfy requirements. We're experiencing something fairly similar to this. There's a whole breadth of subsystems and drivers in Zephyr. Even more so when you look at the rest of the modules that are on there in the Zephyr ecosystem. That kind of gives you an idea about common architecture. It is this cohesive, all-encompassing thing. How well do the current pieces fit together? Not as well as I'd like, and not as well as I'm used to. There's a lot of configuration that needs to be done. In a real mature product line implementation, product line architecture implementation, it is literally the checkoff items. It's almost like going to a fast food restaurant. It's like, well, do you want mayo or not? Hold the pickups. Oh wait, Burger King commercial. Okay, domain architecture, breadth of capability. Application architecture, what's the subset I'm building? It's a down selection. Doesn't have to be a strict down selection to meet the terminology. What I found in practice with the HP stuff that helped make us extremely successful is even if you started with a functionality that was unique to one product, you better have planned it's going to get integrated in some other one. Basically, our product stuff was just a configuration file, set of configuration files and builds. And that really became beneficial over time. Have a chance to ask questions on this later. Okay, so the scope of this talk, the title of this talk dealt with product line scoping. What do we mean by product line scoping? The process for defining the member products that will be produced within a product line and the major common and variable features among the products. You're going to have to decide what the scope is for all the products that you're going to build out of this. What are you going to support? You will support at least the set of products you have in mind. Hint, define your boundaries a little bit larger than that. Because before you know it, marketing is going to come along and say, oh, we need to have this in there, or we need this alternate configuration, or we've got this other product concept. So you can actually hurt yourself by optimizing. Scoping is figuring out what the range is of what you're going to do. Now, is that a static range for the entire lifetime of the product line? No. It's going to evolve over time. As a matter of fact, I mentioned smart camera dock earlier. When in HP we started off with this product line for the desktop printers, that was not in our imagination. We ended up churning a generation of architectural improvements in that product line every year. We would deliver a year of products. We would figure out what we need to improve. We would apply the improvement. We would do the enhancements for the next year of products. Sometimes it was technology bump. Sometimes it was feature capabilities. About 4 generations into it, they said, you know, we've been doing printers. We know how to do multifunction machines. Let's look at another business opportunity. We've got these HP cameras over here. Let's make a wireless smart camera dock. And a couple friends of mine were working at another end of the same building I was in. And they say, Greg, come on over here and help us figure out how to turn this thing on. We had tied on to having a print engine. It's like, oh, with all the separation we've done with fax and scan, on is still tied to the print engine. So we had to refactor, tear that apart so that we had an alternate implementation of this particular component that was simplified so they could turn the product on and off. That kind of scope change, that kind of refactoring, just part of life. It's part of tracking the business. But figuring out the common and variable features, a lot of what that meant for us was figuring out the infrastructure, figuring out the relationships of those things, and sometimes accepting less than the most efficient implementation of some functionality. Good example of that. We had one group that was doing single function printers. We had another group that was doing fax machines. Did you know that you can delay and schedule when you want your fax to be sent? Based on calendar time, you load up the image earlier, it stores it off to the side. When the time comes along, it needs to go through, dial the phone, send the information out. That meant that our job scheduler had to be fairly rich. When you've got a single function printer, the data comes in, the data goes through, the data goes on the paper. Worst thing you get is, I can't put the data on the paper because there's no paper there. And we had this cultural struggle. Do we have 2 implementations of job scheduler? And we have to maintain 2 implementations of job scheduler? Or do we just accept the complexity of the one that must be used inside of fax machines? And this was a real cultural struggle because we're used to minimizing those things. We went with the one. Turns out it's a really good thing we went with the one, because then we started looking at some of the other requirements, like demo pages, like having to service the print engine. Those all require resources. They require, some of the resources are RAM, some of the resources are pieces of hardware. They require certain schedulings to be done. Then we started getting into print engines that required them to schedule their own maintenance periodically. Oh, if you haven't printed in the last week, then I'll have to go through and automatically do the servicing. So the caution out of that is be careful about identifying what's common and be mindful for covering the breadth of capability as opposed to individual point. Oh, we got to run through this. Okay, final term, product line platform. Product line architecture, a configuration management plan, and a domain assets. I'm not going to talk much about this. It'll come back up later, but I wanted to let you know this term comes from the standard definitions. Okay, product line engineering process. We have to blow through this quickly. I've got about 7 minutes left. Really simple. What's the scope of the problem? Captured as user needs and stakeholder requirements. How much of the problem are you going to solve? Captured as system requirements. What does your solution look like? Captured as system architecture definition, and you can read the rest of it. You're going to decompose, you're going to define the boundaries of that system. What are the external interfaces, user interfaces, and that type of stuff. You're then going to decompose how do you do it inside. And you're going to keep doing it down until you get to, as was referenced in one of the other talks, a solid solution. Single responsibility, I forget what some of the other ones are. That's an acronym you can look up, SOLID. Basically a pretty thorough design. So what's the extension when you get to product line? You have to identify common and varying functionality between the elements. You have to have a common way of doing variation management and configuration. Can you say K-config? You have to identify the subset of system elements to build for this product line platform. The architecture identifies the things at the bottom. Pictures are worth 1,000 words. So let's go through this fairly quickly. Defining the problem space. Personas, user needs, business needs, constraints like regulations. All right? What I've got up there are some icons for a range of types of problems that we could be solving. That's business potential. What we're going to do is try to solve the one in the lower left-hand corner because I thought the bat icon was kind of cool. So, negotiate your solution space. We're talking about IoT products. So we got IoT products over here. We know that there's going to be cloud services associated with it. There's going to be service centers associated with it. There's going to be mobile platforms that people are going to connect to it with. So, what is outside the system? The parts we don't provide. What is inside the system? All the parts we do. So, the system includes applications on the mobile platform. The system includes software that runs on laptops. The system includes our IoT devices. And it's really important to understand what the bounds are of your system. Go a little bit farther. We have to decide how the system is going to get decomposed. This is where we're talking about what are the protocols that are being used to interface between these things, what are the responsibilities of them, how many cloud services are there, and what do each of them do. Some of this stuff is going to be standard. Some of the stuff is going to be value added. And that's really a balance point you're going to always be faced. If it was always just a standard solution, it's probably going to be available by somebody who's going to do it less expensively than you, or it's going to be available open source. There will always be value added that we have to consider in this. You can read the rest of the slide. Let's go a little bit farther. Product line does not mean that it has to cover everything. You have to look at commonalities, functionalities, and that kind of stuff. So in this particular case, they said, oh, gee, we've got iOS and Android. I make one app, it may have different functionalities on there, or maybe I've got a pair of apps that I have to put on each platform. One of them for the user, one of them for testing. Want to reuse the protocol stack implementation between them? It's a reasonable proposal for product line. Similar thing between what's on a desktop and what's on a cloud service. There may be opportunity there for commonality. Do I have a web interface to what's on my desktop? But this really is the one that I wanted to talk about over here. We've got a range of mechanics, we've got a range of electronics, and we decided we don't have to cover all solutions. That's perfectly okay that we don't have a gas camping lantern as an IoT connected device. We may provide it as filling out the solution space, but it doesn't have to be covered in the product line. Okay? You can read the rest. Here's a list of opportunities to look for commonality. And notice they're not dealing with implementations, they're dealing with capabilities, functions. Once you identify one particular thing, and we're going to use the IoT devices, then you have to design an aggregate topology, responsibilities, protocols between them for how are you modeling, how are you decomposing the building blocks for your device. This particular pattern I've been forming in my mind for a couple of decades. Just kind of letting it sit back there, see if it all makes sense. UI is a really high level thing. It has to be able to issue commands going down. It gets asynchronous notifications of changes on there. Device drivers are way down at the bottom. Services talk with engines, print engine, scan engine. Telecom probably gets modeled as a communication thing here. Food for thought. Oh, interesting thing. Shutdown. You remember what I said about the smart camera dock? Shutdown is really important. I really miss that Zephyr is missing it. That's really a problem. Control shutdown of the system. Okay, let's see. About out of time. So an individual product on here builds a subset. Could be alternate implementations. Could be alternate stacks. Protocols. Oh, I've got Wi-Fi here. I've got wired Ethernet there. Engines. Oh, gee, my single function printer doesn't have a scan engine, but my fax machine does. Now, nothing different in the marketing. Application of the product line engineering to Zephyr ecosystem. What we're going to cover right now are the standard product line models. We don't have to reinvent the wheel. Pictures are important. So we talked about domain engineering, the breadth of stuff. Over on the right, you'll find out the things that struck me that already exist in Zephyr that map to domain engineering. Right? Zephyr product mission statement, downstream Zephyr users as part of the scoping. Domain assets include the build system, the SBOM generation, licensing checks, documentation, domain verification, test runners, twister, code coverage. So that's, and what happens down here with application assets? The example application repository, it's not domain engineering. It's a current, we set it up for you guys to be a template for how you can organize a new module or an extension to an existing repository to tie it not only into the Zephyr build system currently, but so that you can draft all of the functional capabilities that come along with it, test runners and all that kind of stuff. But the example application, the samples, downstream Zephyr user modules, that kind of all fits down inside of there. So that actually comes, this picture comes out of the ISO standard that's up on the top. Been in place for a while. This one is actually fairly recent. It's a 2021 standard. It is a feature-based specialization of the previous product line standard. So what they've done is they've taken the domain engineering we talked about, the application engineering that we talked about, the domain assets that are there. They've identified a few other labels. Feature catalog. Can you say collective list of K-configs? There's bill of features, portfolio. What are you building for a particular product? prj.conf. Your overlays. That's what you're building. Goes into a product line engineering factory configurator. Not my name. Can you say build system? You feed those things in, out comes out the content. What's following along through here, these are diagrams of the V development model. We're going to go through that very quickly. Okay, yeah. Development, creation on the left, verification on the right. Validation up at the top can only be done by the end users. You remember that light switch? Not valid. They may have done it right, not valid. Key guidance. Reuse when possible, extend when necessary. This paradigm change is actually really enabling. You're no longer writing or designing things to be leveraged. It's not It will feel restrictive. It is actually really powerful. Let's see what else. Design for reuse security. You can read all the rest of that. Repository-wise, as far as I can tell, Zephyr is not the center of the universe. It's the foundation for my product line. Remember that fifth definition? Zephyr is a product line platform. Downstream modules are getting pulled together into my manifest module. This is where I'm defining my projects. This is the limits of Zephyr RTOS, or Zephyr Project RTOS. Yeah. So summary, we went through the terminology. There's no need to reinvent proprietary terms. We went through the process. Maps well to the standard process. We can go further. Application of PLE to Zephyr ecosystem. It's achievable now. There's room for improvement. Questions?
All right. So we have about 6 minutes before the next, it's a virtual session next, I think. So if anybody has any questions, I have one question, which is, I know you and I have talked about this a little bit, but I think, correct me here, that one of the things you're trying to push for here, or to get the community to recognize, is some of the terminology, right?
Yeah, and a lot of that actually ties back to a theme we have been hearing throughout this conference. Why reinvent the wheel? The terminology exists. It's now been standardized. It's recognized at the ISO level, at the IEEE level. It's what's being used for those that are aware of this technology already. We can shift our terminology easily enough.
Okay. In the audience? No?
I put you guys to sleep?
Maybe. All right.
Okay.
Thank you very much.
Thank you.